Today we're going to talk about how to find the area of a sector of a circle. First thing I'm going to go over is the various parts of what makes up a sector, how we use those parts to then find the area of the circle, and then I'll go over the practice problems that were assigned to you for today's lesson, show you how to do them best, and then go through all the answers, do all 18 problems. So let's start off. What exactly is a sector? A sector is a portion of a circle. It is defined by the section of the circumference of the circle between 2 points. We call this an arc. And then by 2 radii that connect the 2 points, the 2 endpoints of the arc with the center of the circle. On the circle that I've drawn here, our arc is defined by points A and B, right? And we can use the letters A, B with a little arc symbol above them to name that arc. The center of the circle is O. And then we have 2 radii that connect O to point A and to point B. And the section here between the radii of A and B, this all in here is our sector. Okay. We have what's called a central angle. Central angle here is the angle from A to O to B. So it's the angle that has the center as its vertex and has the 2 radii as its sides. And we are noting here that angle AOB is the central angle. The measure of that angle we will call the Greek letter theta. So here my sector is defined by also a radius, the length of radius, as well as the measure of the central angle. And that's what we really need to use to find the area of a sector. Okay? The area of a sector is equal to the measure of this theta, this central angle, divided by 360 times the area of the circle as a whole, so pi r squared. Really, when we're talking about what the area of a sector is, we're talking about what proportion of the circle is covered by the central angle. And we find that proportion by dividing the measure of the central angle, that theta, by 360, which is the measure of the entire circle's degrees. So here, area equals theta times pi, that's the pi that we're always used to, 3.141592, yada, 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 times r squared, that's our radius squared, all divided by 360. So if you know this formula, all you need to know to find the area is what that central angle is and what the radius is. So let's take this formula and let us do the practice problems that I gave you for this lesson. So if you haven't had the opportunity already, I want you to do these first 3 that were on page 1. Pause the video right now, and then when you're done with the problems, come back and I'll go over them. So for number 8, for this first number 8 that we have here, let's remember again, our area equation is theta pi r squared all over 360. Now, if you'll notice here, we're going to be looking at the shaded area. And what is the angle here of the shaded area? What is our central angle? Well, it's a right angle. So we know that theta is going to be 90. Pi is over pi, always pi. And r squared in this case is 6 squared, all over 360. And that is what our formula is going to be, what our equation is going to be equal to. Now, we can simplify this down and get an exact number for it. And let's do get rid of that 0 and that 0 cancel out. And then nicely, 6 squared is the same thing as 36. So our 36 and our 6 squared cancel out. And this is going to be 9 pi. Our units are centimeters squared. We have a nice clean number like 9 and pi. We can keep it like this. This is what we call the exact value of it. So we don't need to plug it into the calculator. Some of the other ones, the rest of them, we're going to plug into the calculator. But this was a nice example of one that if we can keep it in terms of pi, let's go ahead and keep it in terms of pi. All right. Number 9, we're going to be using the same formula. In this case, our theta is 60. Our pi is pi. R squared is 100. And that's going to be all over 360. And then if we take that 60, that 360, we can cancel out. Get down to 6. And then this is going to give us 106 pi, or 50 thirds pi. And it's fine to leave it like that, but we can also plug into a calculator if we want to get something that is more visceral to us, something that is easier to understand. In this case, if we plug it in using the pi button on our calculator, not using 3.14, we will get it to be 52.36 inches squared if we round it to the hundredths place. Number 10. Okay, number 10, the first thing we got to realize is that here at the center, it is telling us that these three angles are all congruent. So that means that any one of those angles is going to be 1/3 of the whole circle. So it's going to be 120 degrees. So in this case, our area is going to be equal to 120 times pi times 24 squared. That's all going to be divided by 360. Simplifying that down, I'm not going to go through that process right now, but I can tell you that it's 192 pi if we just want to keep it in terms of pi. And if we plug this into a calculator, it's going to tell us that it is about 603.19, and the unit on that is feet squared. If you haven't already, give the next 3 a try, and then unpause and listen to me go over it. So number 11, we're going to be, for 11, 12, and 13 here, we're going to be doing the formula in reverse. In each of these cases, we're given what the area is of a sector, in this case, the area of the gray sectors, and we're asked to find some other value on the circle. So for example, for number 11, we're asked to find what's the area of the entire circle that we're given. So let's think about this for a second. Let's remember that the area of a sector, what our formula is equal to theta pi r squared over 360. And this pi r squared, we've seen it already this week. That's our formula for the area of a circle. So we really can rewrite this as theta over 360 times the area of the circle. And that's going to be the formula that we're going to be using here. We're going to say that the area of the sector, in this case we know that to be 17.46, is going to be equal to theta. We're told the theta is 100, and 360 is our number that we always use, and then area of the circle. And then if we just take the reciprocal of this and solve for the area of the circle, that's going to give us a value, once we plug it into the calculator, of telling us that it's going to be 62.856, or I can round that to 86, and that's going to be meters squared because that's what our unit is. Okay, we're going to do the same thing again for number 12, using that same formula and saying that 39.52 is going to be equal to, in this case, 175 over 360 times the area of this circle. Solving for the area of the circle is going to give us a value of approximately 81.30 inches squared. Okay. So in both these cases, this is the method that we use to find the area of the entire circle if we know what the area of a sector is and if we know what the central angle of that sector is. Here, instead, we're going to find what's the radius of the circle. Okay. So there's two things that are tricky here. The first is that the angle that we're given is actually the angle of what's left over after we take out the sector. So to figure out what our theta is going to be, we're going to have to take the 360 degrees that the whole circle is and subtract 78. And once we do that, now we know that the central angle on this one is going to be 282 degrees. That's our new theta. And here we're not solving for the area of the circle, we're solving for r. So let's go back to our original formula. And it's going to be that we know that it's 20.89 is going to be equal to that theta, 282 over 360 times pi r squared. Now I'm going to solve for r squared. So that's going to let me have that it's going to be 20.89 times 360 over 282 pi. Plugging that in a calculator, you're going to get r squared is going to be approximately 8.4887. And now I just want to take the square root of both sides, use the positive value, and my radius is about 2.91, and my unit here is feet. So these are the trickier problems, the more challenging ones, but really not too terribly complicated. All right, now go ahead, give the second page problems a try. Go ahead, do 8 through 10, and then come back to the video once you are done. All right, back to 8 through 10. We're back to using the standard formula for area. So in this case, our area from number 8 is going to be 65, which is our theta for the circle, times pi, times 4 squared. That's going to be our r squared. That's going to be all over 360. Plugging into a calculator, this one is not going to have a nice, clean fraction or whole number really to give you. So we're just going to plug this into a calculator. And I will tell you that once you plug it into the calculator, that it is going to come out to be about 9.08 square inches as the area of this circle. Moving on to number 9. Same formula. In this case, we're going to have 130 as our theta. And really, when we look at a formula in geometry or in pre-calculus, whenever we see theta, we're talking about angles. Generally, theta is a variable that is used for angle measurements. So you're going to see that a lot moving forward. So again, 130 is our theta, pi, and r squared in this case is going to be 27 squared, and that's all over 360. Plugging that into a calculator will give us a value of approximately 827.02, and centimeters squared is our unit here. And finally, on number 10, here again, the trickiness is that we have the angle for the white part. We need to find the angle for the gray part, and that just requires us subtracting what our known angle is from 360, and in this case, that means that it's going to be 151 degrees is going to be our theta. So our area is going to be 151 pi 18 squared, all over 360. And a calculator will tell us that that is 426.94 meters squared. Okay. So again, these problems, it's that same formula. The math is a little bit trickier once we plug it into a calculator, but really figuring it all out, as long as we know how to use the calculator, should not be very difficult. All right, start up the video again when you have done 11 through 13. All right, again, 11 through 13, we are back to figuring out aspects of the entire circle from the known area of the sector. So here, again, we're knowing that our area is going to be equal to theta times area of our circle all over 360. In this case, the area of our sector is 23.79. Our theta is 80. Our 360, O is 360. And area of the circle is our unknown. And rearranging and solving for the area of the circle is going to tell us that this is going to be approximately 107.06, and our unit here is feet squared. Radius. No longer finding the area of the circle. Now we want to find the radius of the circle. So we'll use our good old sector area formula. 40.62 is going to be equal to our theta here, 98 over 360 times pi r squared. Doing a little rearranging, r squared is going to be 40.62 times 360 over 98 pi. Plugged into a calculator, that's going to get us a value of approximately 3.5198, and then taking the square root of both sides will get us to 1.88 inches. That's our unit. Okay. Number 13 on this one. Instead of the radius, we're finding the diameter. So it's the same process as 12. We just multiply our final answer by 2 to get our diameter. So 31.47 is going to be equal to, in this case, our theta we have to subtract the 51 from 360. 360 minus 51 is going to be 309 degrees. So our theta is 309, going to be divided by 360 times pi r squared. R squared in this case is going to be equal to 11.6705. R, once we take the square root, is going to be approximately 3.416, which means that our diameter twice that is going to be approximately 6.83 meters. All right. And that's how we do the reverse problems. Again. All right, we're on to the last page of the last 6 problems from the practice page. So give 8 through 10 here a try, and then come back when you are ready to go. Number 8, same old formula that we've been using. Hopefully it's second nature to you now. So our area is going to be, again, 60 over 360. And then pi 8 squared is going to be our r squared. And this is going to turn out that our area, once we plug into a calculator, is going to be approximately 33.51, and our unit here is inches squared. Number 9, same formula. Area is going to be 120 times pi times 4.5 squared. That's going to be all over 360. So our area is going to work out to be, in this case, nice number, 21.21. Our unit's going to be inches squared. Now, real quick, I want to take a little sidetrack on how do we correctly write pi. Okay, there's two good ways to do it. One, we can start off by just doing our little tilde, or a little twiddle, or a little squiggle, and then we put two lines down. Right. Also, we could just start off with the lines and do it kind of like a fancy double T. Either way is good. What I don't want to see people doing, and I do see this a lot, I've seen it a lot with the pre-calculus students that I teach, is to just do something like that and think that that kind of looks like pi. Okay, I'm going to tell you that is a completely different Greek letter. It's a letter called mu. Okay, these two things are not equivalent. And if you write down mu, you are going to be terribly confusing whoever is working with you on the paper, especially if they're really good at math, right? Mu is representative of things such as friction, and it stands for micro when we're talking about units. We can have micrometers, where we have millimeters in the past, and centimeters. We can have micrometers, which is 1/1,000,000th of a meter. Okay. Don't write mu. Get used to drawing pi's as they are. It's a very important number, very important symbol to write down, so get used to drawing it. Okay, we're going to finish off with our last circle here, or our last sector, and we have 110 as our theta times pi times 12.8 squared, all over 360. And the calculator machine will tell us that it is 157.28 millimeters squared. All right, let's do the last three problems. So if you haven't already done them, give them a try, unpause when you're ready, and let's go through them now. Okay. Number 11 is a good old area of the circle. So we're going to take 336.07, set that equal to 58 over 360 times the area of the circle. Once we solve for what the area of the circle is, we're going to know that that value is 223.88 centimeters squared. Here we're solving for the radius, so we're not going to use the area of the circle formula. We're going to use the regular formula. But again, here, look, we're given the angle of the white part. We need the angle of the gray part, and it turns out that that's 199 degrees. So we know our area here is 84.14. That's going to be equal to 199 over 360 times pi r squared. R squared is going to be equal then to 84.4 or 14 times 360 all over 199 pi. Thus, r squared is going to be approximately 48.4509. That's going to give us a radius of around 6.96, and our unit here is meters. Our final problem asks us to find the diameter of the circle. So again, we're just going to find the radius, multiply by 2. And here again, we are asked to figure out what the angle of the central angle is here. And in this case, our central angle, our theta, is going to be 109 subtracted from 360 is going to get us 251 over 360 times pi r squared. R squared When we solve for it, it's going to become 33.0489. Taking the square root of both sides gets us a radius of approximately 5.749, and doubling that and rounding off to the nearest 100th gets us 11.49, and our unit here is feet. So there we go. That is an overview of how to figure out the area of a sector of a circle, and then take the area of a sector of a circle and figure out the radius or the diameter or the area of the entire circle. If you have more questions, please find me during office hours. Otherwise, I hope you all have a wonderful weekend.